So in section 5, the last section of module 1, we're going to talk about interval notation. And first we have to actually define what interval notation is. And it is a notation for representing an interval or an inequality is how we're mostly going to see it, as a pair of numbers. And these numbers are the endpoints of the interval. So a couple things about interval notation is that we can actually have two different types of endpoints. We can either use parentheses or brackets. And when we use parentheses, that represents a greater than or less than inequality because the number is excluded. And then we can also use brackets, which is if we have a greater than or equal to or less than or equal to inequality. And that's because the number is included as part of the solution. So let's take a look at some examples. So there's a lot of different types of inequalities you may see and need to know how to write them as an interval. So the first is just a regular inequality, such as x greater than 7. So we want to write the interval that represents every possible number greater than 7. So I would start at 7 because it is greater than, and there's really no endpoint for numbers, which means it would go on to infinity. So because it's a greater than sign, I know that 7 is not included as a solution, which means I need to use a parenthesis. And then I just have to figure out what type of bracket to use for infinity. Well, the nice thing is anytime I use infinity, it's always a parenthesis, since infinity is a concept, it's not an actual number. So next we want to look at x less than or equal to -1. Well, anytime we're less than or equal to a number, the number we have is the greatest value we can have. So -1 is actually going to be on the right side of our interval, and because it's equal to, it's going to have a bracket. So when I talk about the smallest number less than or equal to -1, there's really no end. So we actually have negative infinity to start with. And just like with infinity, it gets a parenthesis. So anytime you see positive infinity or negative infinity, always have to use a parenthesis in the interval notation. So let's take a look at compound inequalities. So those would be and or inequalities. So the first set we're going to look at are and inequalities. So I have -7 is less than x is less than 4, which the solution means that I can only have values of x between -7 and 4. So these numbers are going to be my endpoints. My interval has to be everything between -7 and 4, and they're both strictly less than, which means I'm going to have parentheses with both numbers. Next we have the inequality 9 is less than or equal to x is less than or equal to 13, which means x is between the values 9 and 13. So we have 9, 13. And both of these inequalities have equal to's, which means the values are included, which means they have brackets. Now with compound inequalities, the inequality does not have to be the same. One side could be a parenthesis and one side could be a bracket. And that's what we're going to see in our next example here. This is x has to be between -14 and 21, but it can be equal to -14, but it has to be strictly less than 21. So my numbers are still -14 and 21, but I'm going to have a bracket with the -14 since it's included and a parenthesis with the 21 since it is not. So my last example here is an example of an or inequality. And anytime we want to write the solution for an or inequality in interval notation, we have to use something called a union. because as long as my value falls in either one of the inequalities, it's true. So we actually write 2 intervals for the solution. And we always start with the less than or equal to, because we want to start with the smallest possible values and end with the largest, like with all of the other intervals we've written. So first I'm going to start with the less than or equal to -9. So I'm going to have -9 on the right with a bracket, and I'm going to have -infinity with a parenthesis. Then I'm going to have my union, and then I'm going to write the x greater than 12. So I start with 12 and I end with infinity, and both of them get parentheses. Next, we can also, given a number line, take the inequality it represents and write it in interval notation as well. So the first number line we have here says everything from 1 to infinity, and then we have a closed circle at 1. So depending on what a closed or open circle means, tells us something different. So if we have a closed circle for our inequality, that means the number is included as part of the solution. If we have an open circle, it means the number is excluded. It's kind of like an equal to inequality, or strictly greater than or less than. So the type of circle we have at our value helps us determine if we need a parenthesis or a bracket. And you're more than welcome to transform the number line to an inequality first before writing it as an interval. So for example, my first number line here tells me that my value x has to be greater than or equal to 1. Because everything to the right of 1 means greater than, and because closed circle means equal to. So when I write the interval notation, bracket with 1 to infinity with a parenthesis. Our next number line, that inequality says x has to be less than -2. Everything to the left is less than, open circle means no equal to. So the way the arrow points can help you determine what type of inequality you have. So everything less than -2, we start with -infinity, we end with -2, both of which get parentheses. We can also graph compound inequalities on a number line. So anytime you're shading between 2 points, that would be a compound inequality for and. So this says I want everything between -5 and 5. So it says x is less than 5, but greater than -5, everything between. So as an interval, this would be -5, 5, both with parentheses since they are both open circles. In the last example here, two inequalities graphed on the same number line would be an example of an OR inequality. So my first one says that x is less than -2, or x is greater than or equal to 3. So when we write it as an interval, we start with the less than inequality first, so everything from -infinity to -2 with a parenthesis, and then union, and then we have a bracket 3 to infinity. So hopefully when you do the Section 5 assignment, you are comfortable with writing the solutions to an inequality as an interval, which we will be writing intervals a lot throughout the school year, so this is something you will be using for a while.